16 Psyche is an M-type asteroid and possibly the exposed core of a protoplanet. NASA's Psyche mission is the first ever trip to a metal world. The first stage of this mission is an orbiter designed to study the asteroid and send data back to Earth. Our project is focused on a hypothetical future mission to Psyche. The focus of this hypothetical future mission would be to utilize the resources found on Psyche in a process called ISRU, or In Situ Resource Utilization. So our first step was to assess what kind of resources Psyche had to offer. Through our research, we found that Psyche was mostly metal and rock. Psyche's surface is approximately 30% metal, mostly nickel and iron. It is also roughly 3 times farther from the Sun than Earth, and therefore it's very cold. The average temperature is 120 Kelvin, or -244 Fahrenheit. Psyche does have gravity, but it's very low, about 1.5% of Earth's gravity. Based on Psyche's available resources, our team decided to focus on refining the metals present on the surface. The final design is a fully autonomous vacuum distillation chamber. Here, the external case is shown to highlight its convenient design features. On top, raw material is fed in through the input port. The front side features a waste hatch, output hatch, and mold storage compartment. On both sides, there are heat vents to allow radiant heat to escape from the chamber. In the rear, there's a service door to access any internal components. Let's take a look inside the box to see how it all works. This diagram shows the basic functionality of the distillation system. First, material is input from the top port. This material falls into the transfer chamber in the plunger, pictured here in red. The plunger then transfers the material into the heating chamber and returns to its initial position. The material is vaporized by induction heating and then condenses on the inner walls and within the cooling chamber. At this point, any unwanted materials are vented through the waste port. The waste port's door mechanism is shown here in orange. The system of plungers then scrape the walls clean to collect any powdered metal and prevent material buildup. Finally, the refined materials are retrieved from the material output hatch. This system is designed to produce refined metals in ingot, bar, and powdered form. In addition to the system design, the team performed an experiment to test the process of vacuum distillation. The prototype is shown here. This setup required a vacuum pump and chamber, 240-volt power supply, and a heating coil. The chamber was modified to include a distillation chamber. The experiment's intent was to test vacuum distillation on tin and collect any vaporized particles in the cooling chamber. While no material ended up vaporizing and recondensing, video footage captured during the experiment appears to show bubbles in the molten tin, indicating the tin possibly began boiling. Finally, the team had to make a recommendation for the scale of the model that would hypothetically be sent to Psyche. For this hypothetical future mission, the team is recommending a 1/10 scale model of the system powered by 10 square meters of fold-out solar panels. This recommendation was made based on the availability of solar power on Psyche and could of course be scaled up or down to accommodate differing needs. At this scale, the system is capable of refining 1/2 kilogram per day of raw materials and produces a total of 55 kilograms refined materials per year. Since the 1/10 scale model weighs just under 50 kilograms total, this system is capable of breaking even in less than 1 year.